All right, everybody, you ready to learn about the circumcenter? So the idea is that you take the three, everyone, this is geometry. All right, so we're going to talk today about medians, altitudes, and mid-segments. So let's get started. First, let's talk about medians. What is a median, you might ask? Well, a median of a triangle is a segment whose endpoints are the vertex of a triangle, or the top point, and the midpoint of the opposite side. The point of concurrency of the medians of a triangle is what we call the centroid of a triangle. The centroid is always inside the triangle, always. It can't not be. The centroid is also called the center of gravity because it is a point where if you have an actual triangle and you put something underneath it, it will balance. So like if you were making a triangular table, you would want to put the stick right there at the centroid. So let's talk a little bit about the centroid. The centroid of a triangle is located 2/3 of the distance of each vertex to the midpoint of the opposite side. So the centroid is 2/3 of the distance from the vertex to that midpoint. So in this case, if the whole length of the median was 39, then the distance from the vertex to the centroid would be 26, and the distance from the centroid to the midpoint would be 13. You can see that down here, that one of those sections looks considerably longer than the other. It should be exactly twice as long. So let's talk about how we find the centroid now. You will use the following formula to find the centroid. It's x1 plus x2 plus x3 over 3, and y1 plus y2 plus y3 over 3. If this looks similar, it's because it's basically the midpoint formula, but with a third point added in. So let's find the midpoint, let's find the centroid for a triangle with vertices at 1, 7, 4, -5, and 10, 1. So to do that, we have to plug in our values. So our x values are 1, 4, and 10. So 1 plus 4 plus 10 divided by 3, and then 7 minus 5 plus 1 divided by 3. 1 plus 4 plus 10 is 15, and 7 minus 5 plus 1 is 3. So we get 15 over 3 and 3 over 3, which becomes a centroid of 5, 3. So now let's talk about the altitude. An altitude of a triangle is a perpendicular segment from the vertex of the line to the line that contains the opposite side. Now notice, I did not say to the side. It can be off of it like we see right here. This is an obtuse triangle. Every triangle actually has 3 different altitudes based off of vertices, as you can see right here. An altitude can be inside, outside, or on the triangle. So the point of concurrency for the altitudes is known as the orthocenter of a triangle. And so let's look about how we get to the orthocenter with some different types of triangles. We're going to start with an obtuse triangle. And as you can see, the obtuse triangle's altitudes all end up meeting outside of the triangle. So the orthocenter is outside on a obtuse triangle. On a right triangle, you will notice that the orthocenter ends up being right there at the 90-degree angle of the right triangle. The right angle is the orthocenter of a right triangle. And then finally, with an acute triangle, the orthocenter is just going to be kind of in the middle. If anything, the orthocenter kind of makes the acute and the obtuse triangles look very similar, although there are obviously some major differences. So now let's talk about mid-segments, and this is our last thing for this video. So a mid-segment of a triangle is a segment that joins the midpoints of 2 sides of the triangle. Every triangle has 3 mid-segments, and these mid-segments form a mid-segment triangle. So here's a mid-segment right here. It goes from the midpoint to the midpoint, and it is going to be parallel to that bottom line. In fact, each of these are parallel to the point that, like I said, forms a mid-segment triangle. And then a mid-segment of a triangle is parallel to the non-included side of the triangle, and its length is half the length of that side. So say if the bottom was 10, the mid-segment would be 5. Kind of looks like a Triforce. All right, with that, please make sure that you like and subscribe. Thank you all for watching. There we go. Have a good day. Good day, and here we are with a beautiful, beautiful kangaroo who's running away from me. Time to learn geometry.